At first, it seemed like nothing out of the ordinary. Just another sunspot appearing on the eastern edge of the sun. Sunspots come and go all the time, their fleeting presence a routine occurrence in the vast solar landscape. But as the days passed, this particular sunspot began to grow at an astonishing rate. What started as an unremarkable blemish on the sun's surface soon swelled to a size 17 times larger than Earth itself. Scientists labeled it Active Region 3664, and it did not take long to justify its name. This colossal sunspot unleashed powerful solar flares, some so intense that they triggered coronal mass ejections, CMEs, hurtling directly toward Earth. The result was one of the most dazzling auroral displays in recorded history. Vibrant waves of light stretching across the skies, illuminating regions that had never witnessed such celestial beauty before. According to NASA, this was the most powerful geomagnetic storm in 500 years, so strong that it even disturbed observatories buried deep underground. Even after the intense storms of May, the sun showed no signs of calming down. Instead, it continued to emit bursts of M-class and mild X-class flares, keeping space weather experts on constant alert. Then, on October 3rd, an enormous X9.0 class flare erupted from the very center of the sun's disk, the most powerful flare observed in 7 years. Within a week, Earth was struck by a severe G4 geomagnetic storm, lighting up the skies with breathtaking auroras in unexpected places and causing disruptions in radio communications across the globe. All signs pointed to one thing: the long-anticipated arrival of the solar maximum. And now, NASA has officially confirmed it. The sun's magnetic field has flipped, marking the peak of its activity. What is the solar maximum? Though the sun appears to be a constant, unchanging ball of fire, it is anything but steady. Every 11 years or so, it undergoes a dramatic transformation known as the solar cycle, a period of fluctuating activity that influences both the sun's magnetism and appearance. The discovery of this cycle dates back to the late 18th century when astronomers, while observing sunspots, dark patches on the sun's surface, noticed an intriguing pattern. These sunspots were not randomly distributed. Instead, they appeared and disappeared in a rhythmic cycle, peaking in number roughly every 11 years. Over time, scientists realized that this cycle also involved significant changes in the sun's magnetic field. Our sun, a massive sphere of charged gas or plasma, has a constantly shifting magnetic field. With each solar cycle, this magnetic field undergoes a complete reversal. What was once the magnetic north becomes south, and vice versa. This pole reversal occurs around the time of solar maximum, marking the cycle's midpoint. Solar maximum is also the period when the sun exhibits its highest level of activity. Sunspots, solar flares, and coronal mass ejections all reach their peak, sending bursts of charged particles hurtling through space. Monitoring solar cycles now involves tracking these factors: sunspot counts, magnetic field reversals, and overall solar activity. The history of solar cycles. Since the discovery of the solar cycle, astronomers have meticulously recorded each one, assigning them sequential numbers. We are currently in solar cycle 25. While most cycles follow the expected pattern, rising to a peak, then gradually declining into a quieter phase, history has seen exceptions that continue to puzzle scientists. Two particularly unusual periods stand out. Between 1645 and 1715, the sun entered a phase of extremely low activity known as the Maunder minimum. During these 70 years, sunspots became almost non-existent. Astronomers recorded only around 50, compared to the thousands that typically appear in a single cycle. This extended solar minimum coincided with a time of unusual cold, known as the Little Ice Age. Rivers that rarely froze, such as the Thames in London, were covered with ice, and much of Europe endured bitterly harsh winters. A similar but less extreme event, the Dalton minimum, occurred between 1790 and 1830. Like the Maunder minimum, this period of reduced solar activity corresponded with a cooler climate. Volcanic eruptions, including the catastrophic 1815 eruption of Mount Tambora, further contributed to global cooling, leading to the infamous year without a summer in 1816, when crop failures and food shortages plagued Europe and North America. Solar cycle 24, which began in 2008, was one of the weakest in over a century. Scientists were surprised by its low activity, as it produced far fewer solar flares and coronal mass ejections than expected. This raised questions about the variability of solar cycles and the possibility of a future grand minimum, similar to the Maunder minimum. When the current cycle, solar cycle 25, began in December 2019, predictions suggested it would be even weaker. However, these forecasts turned out to be wrong. By August 2024, the daily sunspot count had surged to 299, more than double the expected value and the highest in over 20 years. Furthermore, the cycle's peak arrived earlier than anticipated. While initial projections placed the solar maximum in mid-2025, updated forecasts now suggest that it may have peaked between January and October 2024, with sunspot numbers ranging from 137 to 173. The impact of solar storms. Throughout history, powerful solar storms have left lasting imprints on Earth. The Carrington Event of 1859 remains the most intense solar storm ever recorded. On September 1st, British astronomer Richard Carrington observed a massive solar flare. Hours later, a coronal mass ejection slammed into Earth, triggering a geomagnetic storm so intense that telegraph systems across North America and Europe malfunctioned. Some operators even received electric shocks, while others found their machines functioning without any power, solely driven by the storm's induced electrical currents. Auroras were seen as far south as the Caribbean, casting the night sky in an eerie glow so bright that people could read newspapers outdoors. Another devastating event, the New York Railroad storm of May 1921, disrupted railway signaling systems and even sparked fires in telegraph stations. In 1989, a severe solar storm caused a massive power outage in Quebec, leaving 6 million people in darkness for over 9 hours. More recently, in 2022, a solar storm led to the premature loss of 40 newly launched Starlink satellites. Today, our heavy reliance on technology, satellites, GPS, communication networks, and power grids, makes us more vulnerable to the effects of extreme solar activity. A solar storm on the scale of the Carrington Event could inflict economic damages ranging from 60 cents to $2.60 trillion in the U.S. alone.